Hello students, in this lecture we are going to determine whether this system y of n equal to n x of n is memoryless, time invariant, linear, causal or stable. Okay, so this is the corresponding block diagram representation of the given system y of n. So we have x of n and the n which is multiplied, and we will get the output y of n equal n x of n. Let us determine one by one. So we are going to first calculate whether y of n is a memoryless or memory system. Otherwise, this is called a static or dynamic system. Memory or memoryless, static or dynamic. So any system depends on future or past is a memoryless system. Let's say is y of, we are going to test. Let us substitute n equal to 0, 1, minus 1. So y of, let's say 0 equal, what is value of n? N 0 multiplied x of 0. Here the output at time 0 depends on the input at time 0. So it has no memory. Y of 1 equal 1 multiplied by x of 1. So now the output y of n at time 1 is depends on the input at time 1. So y of minus 1 minus 1 x of minus 1. So again the output at the time index n equal minus 1 depends on the input x of minus 1. So the system require no memory. So therefore the system is memoryless. Second, whether the system is time variant or invariant. Let's say this is x of n, this is n, y of n equal n x of n, this output. So to identify the time variant or invariant, first we have to delay the input and we have to observe the output. So delay the input, let's say I call it as y of n comma k. When I delay the input by k units, let's say I have delayed the input x of n minus k times. Now I am going to observe the output. The output is y of n comma k. What is y of n comma k? That is n multiplied by x of n minus k. Okay, I am delayed the input alone and I am going to observe the output here. So if I delay the input, I will get y of n equal to this x of n and this n multiplied. Okay, so next what I am going to do is I am going to delay the output. I am going to delay the output, which is called as y of n minus k by k units. If I delay the input, if I delay the output by k units, I have two terms of n here. Here n, I have here n. So y of n minus k equal, if I delay the output, I'll get n minus k multiplied by x of n minus k. Now y of n comma k is not equal y of n minus k. Therefore system is time variant. If both y of n comma k equal y of n minus k, in that case we say the system is time invariant. Okay, the condition is simple. Next, we have to calculate whether this is linear or non-linear. First we have to determine the individual responses and then we have to calculate the combined response. let's say we have to calculate the individual responses. Let's say a1 x1 of n. That case the output is y1 of n equal a1 n x1 of n. Let's and the second input is a2 x2 of n, y2 of n equal a2 n x2 of n. So this is the individual responses of the input. If the system is a1 x1 of n, then the output will produce y of n equal to a1 x1 of n. Similarly this. Next, what I'm going to do is I'm going to compute the output, the combined response, that is a1 x1 of n plus a2 x2 of n. Now what is output? The output y3 of n. If I substitute this response to the x of n, I'll get n a1 x1 of n plus a2 x2 of n, a1 n x1 of n plus a2 n x2 of n. This is the combined response y3 of n. What is the individual response? y1 of n plus y2 of n. The individual responses are a1 n x1 of n plus a2 n x2 of n. Now this y1 of n plus y2 of n equal to y3 of n. Therefore system is linear. Okay, next we will see whether y of n equal n x of n is causal or not. If any system depends on future inputs, we say the system is non-causal. Here the output y of n depends on x of n alone. Therefore the given system is causal system. Here also we have to check for the three cases n equal to 0, 1, minus 1. As the output y of n depends on the corresponding time index, we can say this is a causal system. Last one, we have to check whether it is stable or not. We know when we test the stability of the system, we substitute the bounded input for x of n. What is bounded input? You can refer my previous videos. We'll take the bounded inputs or the unit step input or some constant, and we have to check whether the output is bounded for all time n. Okay, let's take the unit step signal for discrete time system 0, 1 up to infinity. The time index is n. This is u of n. Okay, and I'm going to substitute for x of n. First, I am checking the output at y of 0. What is my output? What is n? N is 0. X of n is 1. Instead of x of n, I am substituting the u of n. What is u of n value at time 0? It is 1. So I'll get 0. This is some constant. Let's say the 0. Next I am checking the output at time index 1. I'll get 1. Let's say this is bounded. I am substituting the bounded input and the output is bounded. Let's check. I am checking at y of 10. 10 multiplied by 1, I am getting 10. This is also bounded. I am checking it, let's say 1000, the time index. I am getting 1000. This is also bounded. I have to check the time index at infinity also. In that case, when I substitute n equal to infinity, I'll get unbounded. So system is unstable. Okay. So if a system produce bounded output for all the bounded input for all time index n, we can say the system is stable. Since this system produces infinite values at n equal to infinity the time index, the system is unstable. Okay. So if you want to know more about this stable and unstable system, you can watch my videos where I have solved more number of stable and unstable problems. Thank you.